Hello, I'm Daddy from Austin and Daddy Doodle Doo, and today we are going to wire up a light with what they call three-way switches on each side. So this is a light bulb. If you look at it wrong, it might look like something else, but don't worry about that. It's a light bulb with two contacts, right? And then here is like basically power. So we're simulating this part of the house power circuit as a generator to ground, right? So here's the hot part. And then like a grounded conductor here. Oh, sorry. Okay, generator, black wire. Here we go. So we call hot. And then the white wire, which we're pretending, simulating, is going after some distance to ground, right? And so since the other side of this generator is at ground, that means these are connected, right? And so we have what we call hot and neutral. Okay, so we're going to use what they call three-way switches. So three-way switches are single pole double throw switches because you've got one pole that you're switching amongst two different options, right? And we're going to check the switch because what we got right now is we've got these switches already wired in, and then this part of the house actually was part of a circuit that we redid in order to get these big ass TVs on the walls and some other stuff that we've been doing. It's pretty cool, you know, mostly buttoned up. All right, that's what that actually is. So that was a part, and then while it was a part, I thought that the part of the circuit that was I left out, I just left that the part that we're going to put together today. I just left out because I wanted to get everything else back on, and I thought that power actually powered downstairs. But it doesn't actually power downstairs. It just goes to a switch downstairs with two other switches. And the reason why my lights weren't coming on is because the bulbs were dead, right? So figure that out now. So we're going to fix this now. And it's just a simple wiring job. But what we're going to do here in a second is we're going to get a multimeter and figure out, because there's a white wire, a black wire, and a red wire, right, that go to this switch. And so we want to figure out which colors they are on this switch. And we got another one over here, right? Same kind of switch. I should draw it. I should draw the switch in the middle, right? So, all right. So there are three wires coming out of this switch. So we're gonna figure out what the colors of those are, and that'll help us figure out how to wire up our circuit so that one, we don't trip the breaker, and then have the TVs turn off, right? And then also so that when we flip the switch, the light comes on to the stairwell going downstairs. All right, stand by. All right, here's the switch. All right, so like I said, we got a black wire, a red wire, and a white wire. We just need to know how they're connected. And here's a multimeter. It says there's an overload of resistance. This is what the setting we're looking at. We're plugged into the right sockets to measure resistance. So I can't really do that. I keep saying I'm going to get the camera set up, and I haven't done it yet. So like right now, the switch is in a certain position, and I want to know is the red and black connected? All right, and the answer is no, because it still says OL, which stands for overload. So then if I flip the switch, sorry about the mess. This is a house, project house. It's not really an excuse for all the mess, but we'll get on. I got a cleaning lady that we just hired, or a housekeeper. There we go. All right, so now I flip the switch. And it says about 0. I'm wiggling these. It's hard for me to keep these, for some reason, keep those steady enough to get, but there we go, pretty much 0. So that means when this switch is flipped, these two are connected. So now I need to know what's connected when I flip it the other way, right? So that means I need to know, wait, hold on, switch hands. Okay, so we're gonna check the white wire here. Wait, white wire there. And there's no, oh wait, I got it. The black wire here. Okay, and we're gonna check the number. You can't read it, but I can. That says 0. Okay, good. So what that means is that one way these are connected, the other way these are connected. So that means this is the switched pole between these two throws, right? So black is the one that is connected to each one if the switch is in the right position, all right? So black to the single pole, red and white to the throws. Okay, so we just figured out this wire is black. Oh, you want to show right with my right hand too? I can do it. All right. Okay. Yeah. All right. This wire, say, is white. All right, and this one's red. It's easier to do this on a chalkboard with your non-dominant hand. Okay, so now we know that one. Now we gotta figure out this one. All right. And since you've already seen the process, I'm just gonna figure it out and then write it up on here. Then we'll keep talking. That way the video can be shorter for you. All right, so it's the same thing with the other switch. So the one pole is black, right? It has a black wire connected to it, and then a white wire, and then a red wire for the other two. So what we need to do is figure out how to hook up this hot to here. Let me back this up. There we go. We connect the hot to the right pole on this switch, and then connect the neutral, right? Maybe to the right pole on the switch. And then what are we going to connect up to this lamp, right? So let's start with the hot. And let's go ahead and take it to this single pole. And I may get this wrong the first time. If I do, I don't edit these things yet. Which, sorry for that, by the way. All right, so now we got hot here, right? So let's just connect this white wire here to this white one. And then this red one. Let's just go all the way around the world. I mean, we don't have to, it's our chalkboard, right? So it's our notation. And then, all right, here we go, right? So let's say we got this, in this configuration, this is switched so the white wire is hot, right? So, in this place, this white wire is hot, and this switch is in the position that makes this leg hot. And it happens to be a black wire, which is hot, or, yeah. Hot, right? This one. Now, if we change the configuration of this switch, now the red's hot, right? And the red goes over here, and it's not connected to anything. So that would make this black wire not hot, right? But, so that's good, right? So that's on off right there, if this is fixed. And then if that's fixed, and it wasn't off here, then now I flip the switch this way, and the red hot is passed to the black. So let's just take this. This will be the switched one. I'll run this straight into the light bulb, and then the other end of the light bulb needs to go to neutral, and we're done. Okay. So I'm gonna go ahead and do that. I'll show you. I'm gonna do it in pieces and show you what I did rather than try to make you watch while I do it one-handed. So just a minute. Actually, not just a minute for you. It'll be due to the magic of modern television. It'll be just a moment. All right, so I definitely don't want to make you watch me do all of these or ask you to, but I will point out this is a really cool kind of tool to have. And so I think this is a 12 gauge. So we're just gonna grab it here. And turn it real good and just skin it. Maybe. I just told you this is a cool tool to use. This must not be the right gauge. All right, all right. So we're scanning it. Try this one. All right, so this is a cool tool to use, and so we just get this wire in the right gauge there. Clamp it down, twist it a little bit. There we go. Pull that one off. And then remember, we're going to put the white wires and the red wires together. All right, so now we got these two white wires that we're going to put together. So we're going to grab them by the very end here and twist. This is what we're going to try to do. Yep, there we go. All right. Sorry for the camera angles. All right, so they're twisted together pretty good, I think. No, I mean, I'd like let's give it another one. All right, so we got, just realized it's probably obvious to you, but it helps to be looking at what I'm doing through this phone. All right, and then cut this a little bit off. Oh, I just said that. Got this. But all right. All right. And then we got the wire twisted together. Let's take this wire nut, just twist it. And like these wires are not going to be disturbed, right? Once we get this light put up here, they're just going to be behind the scenes, whatever. But just pull on it. Make sure if they were disturbed, it's not going to come off. And if it wouldn't, it's good. So we got a good electrical connection. We'll bend that one out of the way and then keep going. All right, so we're coming along here just fine, but I just made a mistake that I wanted to point out to you because I don't want you to make it. I'm doing this while the circuit's hot. I could just go turn the circuit off, but you know, all I had to do is add a black wire to that, and then I'm going to add a white wire to the neutral coming from the house, right? Coming from the rest of the circuit. The white, you know, the white and the red. Yep, the white two reds and the two whites weren't hot before, but I was putting this. I was getting ready to attach this ground wire from the house because the rest of the wiring that we've run is grounded to this ground screw. And while I was doing that, it touched this one black wire from the first switch, which was not tied down, right? So as soon as I connected the house power to the switch down there, that nasty switch in my nasty unfinished basement, which before too long will be clean and orderly and also very manly or whatever. We'll do that together if you want, or either way. Anyway, when I did that, this became hot. So I flipped that switch, so now this is not hot. But just anytime you have something like this, we just did a drawing of it and everything, right? So I should have known that this could be hot, and I should have put a wire nut on it so it couldn't touch this black thing, and then this metal, which was touching the ground wire, like it's supposed to be, right? That's the purpose of this ground wire, is so that if the hot thing's touching the case, it blows the circuit and doesn't electrocute you if you touch it because the circuit's off, right? That's why. Another thing to note, I just checked, and after that happened, thankfully, the circuit breaker blew because the TVs don't turn on. So now the circuit breaker's off. So I'm just going to work on it and not worry about it until it's time to button it up. All right, so this is what we're going to be wiring up to that. Remember that black and white wire that we drew, and then I ended up blowing the circuit breaker with the black one, and then I put a jumper on the white union so we can join these together. So you don't have to watch me join these together, but it's kind of nice. Comes with little wire nuts. It's good for 2 wires. So we'll get that on, and then we'll turn the circuit breaker back on, and then we'll test it, make sure it works. It works! And the switch here, it works! Alright, so that's it, right? I'm just going to button that up and put the glassware on the outside of this thing. And again, please sorry about the mess. This is a project house under construction, so it'll end up looking like that. So, yeah, I'll show you the finished product. All right, there we are. Now, as far as the, I dropped this and went down the stairs, the little knob things. I gotta find that. But just the holes in the wall from when we were pulling these wires to get the recessed outlets for the TV, and et cetera, et cetera, et cetera. And having this light helps me see all the other stuff I need to clean, paint, and think about constructing for the rest of the house. So I hope you enjoyed. Austin Daddy Doodle Doo. Have a good one.